Assalamu alaikum wa rahmatullahi wa barakatuh. Now we will talk about the functional areas which are represented on the medial side of the cerebral cortex. Just to summarize the sulci and the gyri on the medial side of the cerebral cortex, this is a frontal pole, this is the occipital pole here, and here is the temporal pole. On the medial side of the cerebral cortex, we have to distinguish this largest commissural fiber, which is called corpus callosum. As you know, the corpus callosum begins on the front, near the frontal lobe, and ends on near to the occipital lobe of the brain as the splenium. Just beneath the corpus callosum, you may remember that we have another commissural fiber which is called fornix. The fornix is another commissural fiber, and between the fornix and corpus callosum we have the septum lucidum, which closes the cavity of the lateral ventricle, and of course we have this egg-shaped structure which is called thalamus. The largest sensory and the relay station of the brain, and here between the thalamus and the fornix we have the interventricular foramen or foramen of Monroe. The interventricular foramen is the only connection between the lateral ventricle and the cavity of the third ventricle, and we have a fissure which runs here between the thalamus and the corpus callosum. This is a choroid fissure in which the choroid plexus of the third and the lateral ventricle is running. About the sulci on the medial side of the cerebral hemisphere, we have the callosal sulcus, which runs just on top of the corpus callosum from the start to the splenium, and just above the callosal sulcus we have another sulcus which is very important. This sulcus terminates as the marginal sulcus, so it's called cingulate sulcus, and the upturned part of the end of the cingulate sulcus is called the marginal sulcus. Here we have the beginning of the central sulcus on the medial side of the cerebral cortex, and on the back here we have the parieto-occipital fissure and also the calcarine sulcus. It's very important sulcus, the calcarine, because as we will say in a minute, it contains a very important area called the visual area. Just to name the gyri which are present on the medial side of the cerebral cortex, here we have the lingual gyrus below the calcarine sulcus, and between the calcarine and the parieto-occipital we have the area called cuneus, as we mentioned in the first lecture, and just in front of the cuneus we have an area called precuneus, and here the paracentral lobule in front of the precuneus. The paracentral lobule is a very important area because it contains a motor and sensory area of the lower limbs, and the rest of the medial side of the frontal cortex is called medial frontal gyrus. And of course, you know, this area here is the cingulate gyrus, or the limbic lobe of the brain, which is continuous below the splenium here with a structure called hippocampus. This structure, as we mentioned, is part of the parahippocampal gyrus on the inferior surface of the brain. So we will start with discussing the functional areas from the back to the front. So the area just around the calcarine fissure here is called primary visual area or area 17. The primary visual area, this is the visual center. It just receives the visual stimuli of the opposite side of the visual field. And if we have a lesion in this area, we will end up with a phenomena called contralateral homonymous hemianopia. This means that you cannot see the opposite or the contralateral side of your visual field. This area 17, is situated just around the lips of the calcarine fissure. So half of the area is represented on the lingual gyrus, and another half of this area is represented on the cuneus. This is very important because if we have a lesion in the visual area 17 in the cuneus, so you will end up with inferior quadranubia, contralateral inferior quadranubia. So you will lose just 1/4 of your contralateral side of your visual field. And if you have a lesion in lingual gyrus, so you will lose the opposite or the contralateral 1/4 of your upper visual field. So a superior contralateral quadranubia. Of course, the rest of the occipital lobe has a function of identification of different visual stimuli that you receive on the medial and on the lateral side. And if you have a lesion in this area, which is called area 18 and area 19, so you will end up with visual agnosia. You cannot understand or you cannot differentiate the visual stimuli that you perceive by visual area 17. This is called visual agnosia. Okay, just in front of the parieto-occipital fissure, we have an area called the precuneus. This area here is called precuneus, in front of the parieto-occipital fissure and the posterior upturned part or the marginal sulcus. This precuneus is part of the parietal cortex on the lateral side. So if you extend this area on the lateral surface, it will continue with the parietal lobe or the cortex on the lateral side of the parietal lobe. And this area, neuroscientists describe the function of this area to store what's called episodic memory. Episodic memory is the type of the memory that usually correlates with different actions or accidents that happens or happened in the past. So it's important in recalling these long-term memories, especially those memories related to the past actions. And this type of memory is called episodic memory. So if you have a lesion in this area, you may lose this type of long-term memory, which is episodic memory. In front of the precuneus, and especially in this area around the central sulcus, we have a very important area called paracentral lobule. The paracentral lobule is divided by the beginning of the central sulcus is into two parts or two halves. Just in front of the central sulcus, the motor area of the lower limb, or the area just below the knee. So this is the motor area, and behind the central sulcus is the sensory area of the leg and foot. Because the paracentral lobule is an extension of the area that surrounds the central sulcus on the lateral surface. So if you continue the paracentral lobule on the lateral surface, it will continue with the motor and sensory area around the central sulcus. So the front of the paracentral lobule usually is responsible for controlling the motor movement of the area just below the knee, which are legs and feet, and also the motor area of the perineal sphincters, and the area behind the central sulcus on the medial side is controlling the sensation, of course, on the opposite side of legs and feet. So if you have a lesion in the area of paracentral lobule, and usually because of involvement of an artery which supplying the whole medial side and the first upper 1 inch on the lateral side, which is called the anterior cerebral artery, so you will end up with a loss of motor and sensory of the area below the knee of the contralateral side, and also uncontrolled sphincter or involuntary control of sphincters of the perineum. Okay, the area just before or just in front of the paracentral lobule here on the medial side is called SMA, supplementary motor area. And if you continue this area on the lateral side or the lateral cerebral cortex, it will continue with premotor area 6, because the paracentral lobule is a continuation of motor area 4, and behind the central sulcus, sensory area 312. So just in front of the precentral gyrus on the lateral surface is located is the premotor area 6. If you continue the premotor area 6 on the lateral surface, on the upper 1 inch on the medial cerebral cortex, you will find this area, which is supplementary motor area, and of course it's a part of the premotor area on the lateral side, and having the same function, but the lesion produce no manifestation, or it is not manifested as the lesion in the premotor area 6 on the lateral surface. Just in front of the premotor area or the supplementary area, the rest of the frontal cortex on the medial side is called medial frontal gyrus. This medial frontal gyrus is responsible for thinking and behavior, higher intellectual abilities, and also controlling the personality of the subject. Also, it has an extension on the frontal cortex on the lateral surface, especially on the frontal pole of the brain, and has also the same function on the lateral surface. So this is a very important area. It's area of personality and behavior, and it's called medial frontal gyrus. As we said, the cingulate gyrus, which is this part here, this is the cingulate gyrus between the callosal and the cingulate sulcus. This gyrus is continuous down here behind the splenium with the isthmus of cingulate gyrus, and continues with the parahippocampal gyrus, as we said, in the parahippocampal in the tentorial surface of the brain. And this is very important. This is called the limbic lobe of the brain, and it's very important in controlling emotions and memory and behavior of the subject. This is the function of the limbic lobe of the brain. Okay, just to summarize the areas on the medial side of the cerebral cortex. So you have area 17. Area 17 is the primary visual center of the opposite side, and it lies in the lingual and cuneus the lingual gyrus below and cuneus above. In front of the right occipital fissure you have the precuneus. The precuneus is responsible for the episodic memory, and you have here the paracentral lobule around the beginning of the central sulcus. In front of the central sulcus is the representation of the motor area of the opposite leg and foot, and behind the central sulcus is the sensory representation of the same areas, and also the control of perineal sphincters. In front of the paracentral lobule you have the supplementary motor area, or the continuation of the premotor area 6 on the medial side, and in front of this area you have the medial frontal gyrus, which controls the behavior and personality and higher thinking. Between callosal and cingulate gyrus you have the cingulate gyrus. Between callosal and cingulate sulci you have the cingulate gyrus, which is continuous in the tentorial surface with the parahippocampal gyrus that includes the hippocampus. Just to summarize the functions of the inferior side of the brain, so you have, this is the inferior surface of the brain here. We will just draw one half of the inferior surface of the brain, or the tentorial surface of the brain, and you know it is divided by the stem of the lateral fissure into orbital and tentorial surface. So this is the orbital surface, and here is the tentorial surface, and of course you know here is the optic chiasma. Optic chiasma is lying on the interpeduncular fossa, the front of the interpeduncular fossa, and in the orbital surface. In the orbital surface we have a very important sulcus here, which is called olfactory sulcus. So this is the olfactory sulcus, and lateral to this sulcus we have here an H-shaped olfactory sulci. Medial to the olfactory sulcus here is a gyrus called gyrus rectus or rectus gyrus, and lateral to the olfactory sulcus is the orbital gyri. All this area, the orbital gyri. All these gyri are part of the frontal cortex and have the same function as the frontal cortex. And also gyrus rectus, which lies medial to the olfactory sulcus, has important function in controlling sexual behavior. Okay, so this is the, as you know, this is the hippocampal sulcus. So the hippocampal sulcus, as you know, separates between the tentorial surface and the midbrain. And you have here another sulcus, which is collateral sulcus, and lateral to the collateral sulcus you have the occipitotemporal. So this is the occipitotemporal sulcus, and this is the collateral sulcus. Of course, you know this gyrus is called hippocampal gyrus, and here this is the medial occipitotemporal and lateral occipitotemporal gyri. This one is the medial occipitotemporal, and the other one, which lies lateral to the occipitotemporal gyrus, is called lateral occipitotemporal gyrus. Okay. In the front of the parahippocampal gyrus, this area is very important, which is called uncus. So this is the uncus. As we described the uncus in the lecture, it contains the center of smell, and in deep dissection of the uncus you will find a nucleus here called amygdala, or the amygdaloid body. The amygdala is part of the limbic system as well as part of the basal nuclei. So the amygdala lies in the uncus, and the uncus lies on the anterior end of the parahippocampal gyrus. Of course, here the parahippocampal gyrus the hippocampus. The hippocampus, which is continuous with the cingulate gyrus on the medial side, and it's a part of limbic loop. The hippocampal or the hippocampus itself has a function of recent memory and consolidation of short-term to long-term memories. So that's all about the cortex on the medial and the inferior surface of the brain, and also the major function of the areas and the lesion which is produced by injury of these cortical areas. Thank you very much for understanding the function and lesion which is produced by these areas, and you may also to listen to the lecture, the online lecture about the blood supply of the brain and cortical structure. And it is very important to link between the blood supply injury of different cortical areas and the lesions caused by the injury of these arteries, especially the area inside the brain itself, which is the internal capsule, the largest projection fiber of the brain. Thank you very much, and I hope we will meet in another online lecture. Good luck for you all.